now. But there is another way of thinking about this choice in terms of graphs rather than algebra. So let's take a look at what that is all about as a reminder for you, those of you who have had intermediate microeconomics. So here is a diagram for coffee, and we'll call this X. And work on my spelling. Then also carrot cake or Y. And you may recall that we can think about the composition of a bundle in terms of the number of slices of carrot cake and the number of cups of coffee that we are willing to buy this morning. So I'm not Vincent van Gogh, so I'm going to be rather clumsy in drawing what we know as an indifference curve. And what is that all about? What is an indifference curve? Taking back to Michael. So this is a representation of all the bundles of cake and coffee that will yield to us the same satisfaction, that is the same level of utility. So we presume that we enjoy both coffee and carrot cake, given the number of slices of cake that we enjoy. We will increase satisfaction by drinking one more cup of coffee. So in other words, the larger utility of coffee is positive. As we drink another cup, our satisfaction will rise. And the same thing for carrot cake. Holding coffee constant, if we consume or gobble down, if you like to about sweets, another slice of carrot cake or satisfaction will rise as well. So the derivative, that is the change in utility that is due to consuming another cup of coffee or another carrot cake slice, is positive. However, on the indifference curve, we are holding the level of utility constant. So in this case, if this is your indifference curve, you are just as satisfied with a lot of carrot cake and just a little bit of coffee, maybe just one cup. This is the case if instead you're drinking a lot of coffee and cutting back on carrot cake, maybe like me, you're on a diet. A point like B right here. So the point to take away about this comparison of points is that both bundles yield the same satisfaction to you. That is, the level of utility does not change along the indifference curve. Okay, so far. So I assume that perhaps you have seen the indifference curve somewhere in the micro class, but if not, or if your memory is rusty, please stop me and we will talk about it in more detail. Now, what is interesting is that the change in the slope of long indifference curve is measuring the trade-off that we're willing to make for one more cup of coffee. So, for example, suppose that we begin at A. Where we are consuming 10 slices of carrot cake. But only one cup of coffee. And now we are thinking about substituting coffee for carrot cake. Let's say at a point such as B, C. At C, we are consuming 6 slices of carrot cake and then 2 cups of coffee. Then what is our trade-off of coffee for carrot cake as we move from point A to point C? Well, let's see. We drink another cup at C in exchange for cutting back on cake by 4 slices. So our marginal rate of substitution, as Navad would say, is 4, or the approximate slope between points A and C. Marginal again just means additional. We're just talking about one more cup of coffee. both bundles at A and C are yielding us the same satisfaction. It would be good then if we could somehow characterize the slope of the indifference term, since it is measuring so clearly the value of another cup of coffee in terms of cake foregone. So let's see what we can do. Here is the utility function for coffee and carrot cake. We can change utility if we wish by either consuming more coffee or more carrot cake. So in general, the change in utility represents the value of another cup of coffee and also the value of another slice of carrot cake. Along the indifference curve, there is no change in utility. A, B, and C each represent the same level of utility. So the differential along the indifference curve is zero in this case. Okay. So let's think more clearly now about the differential of utility. Here is the value of another cup of coffee, the derivative if you've had calculus. Not really necessary for the class, but nice to know. There is the marginal utility of drinking more coffee times the change in coffee. So for example, if we are moving from A to C, dx changes by 1. And the same thing is true for carrot cake. Holding coffee constant, we can increase satisfaction by adding another slice of carrot cake. And then we've already seen that along the indifference curve, there is no change in the level of utility. The VU is equal to 0 in this case. And now that you have seen the derivatives, I'm going to introduce a simple notation. The monthly utility of coffee or X, and also the monthly utility of carrot cake or NUY. Okay, good. So how did we get the slope of the indifference curve? What is now our next step? Well, as you know, the slope for any function is just a change in the y variable carrot cake in this case relative to the change in the horizontal variable X or coffee in this case. So the slope is the change in y relative to the change in x. In our example, they had substituted 1 cup of coffee for 4 slices of carrot cake. So the change was -4 in moving from A to C. That is, we can trade off 1 cup of coffee for 4 slices of carrot cake. But now we have an algebraic solution to the problem of finding the slope. So let's solve for dy and dx. Subtract the change in utility in x from both sides. And retain the change in y on the right-hand side. Okay, good. Now we wrote the slope, so let's divide both sides by dx. And then finally solve for the problem by solving explicitly for the slope, that is by dividing by the marginal utility of y. And there is a marginal rate of substitution. It is just a way of valuing x in terms of the satisfaction that we would have to forego by turning back on y. There is the marginal rate of substitution. Okay, so far. Okay, so I'm recording the session. If you flip the go back and look at the graphs, just take a look at the Zoom file for the recording on the Moodle page for the class. All right, so that's progress. We know how to talk about satisfaction to fair cake and toffee, but it's really not a very realistic picture. Because they're not taken into account the fact that we are constrained by our income in consuming at Starbucks. We don't have enough money to buy all the coffee in the store. So there is one indifferent serve. There is another. As we move northeast in the graph, we increase satisfaction because more coffee and more carrot cake is always better for us. Or so economists think. we can characterize the first indefinite term, for example, as representing all those bundles that are worth 30 euros. And then on the higher indefinite term, we have a higher level of satisfaction, maybe 40 euros rather than 30. Naturally, we want to reach the highest indefinite term that we can. But this all is going to depend on our income. So let's say that we have 90,000 tenge available that will constrain how much we can buy at Starbucks. So I'm going to call income Z. And suppose that we spend everything in our pocket at Starbucks, for example, 90,000 tenge. So we can either purchase coffee at the given price or instead purchase carrot cake. And there is our income reduction constraint. So in the graph, maybe that straight line is representing our budget or income. We can consume anywhere within the triangle because we can afford it. But we cannot consume on this indefinite term because it is beyond what we can afford. So the problem is the maximized utility given our income. We have to be somewhere within the triangle. Okay, good. So suppose that we're bringing in another indefinite term that we can enjoy 20 euros for any bundle along that term. Oh, one possibility is that we could consume right here at point A. Or we could consume at a point like this, call it point B. Question, which point gives us the higher utility, A or B? Well, let's see, at A, we can enjoy just 20 euros of satisfaction, but we can increase our utility by substituting coffee for carrot cake at point B. So the solution seems to depend on the tangency between the indifference curve and the budget, the slope of the budget constraint. Find the highest indifference curve that we can reach with a given income or budget. That point is represented by the tangency at, in this case, of point B. Tangential just means that one function is barely touching the other. By definition, the slope of the indifference curve will be the same as the slope of the budget constraint. But we already know the slope of the indifference curve. This is the satisfaction of another cup of coffee relative to the satisfaction of another slice of carrot cake. But we don't yet have the slope of the budget constraint. So question for you, how are we going to calculate the slope of the budget constraint? So for example, if coffee is twice as expensive as another slice of carrot cake, then along the budget constraint, we can substitute 1 cup of coffee for 2 slices of carrot cake without changing the overall budget. In other words, along the budget constraint, there is no change in our income. And we have already seen that our budget constraint depends upon prices that seem to be constant and also on the amount of X and Y that we are consuming. So let's do the same thing to find the slope as we had done with the indifference curve. Z spending changes whenever we change the amount of coffee and carrot cake that we are consuming. So there is the potential change in spending on coffee. Here is a potential change concerning carrot cake expenditures. And then all of this is equal to 0 because we have the same budget for any point on the budget line, perhaps 90,000 tenge. Okay, so how are we going to get the slope of the budget constraint in this case? Well, let's see. Let's solve as before for the differential d by dx, the derivative. So let's subtract depending on x from either side of the equation. Divide through by dx. And then finally, isolate the slope by dividing both sides by the price of carrot cake. And there is our slope. However, at the tangent point B in our graph, the slope of the indifference curve equals the slope of the buttock constraint of, that is, the relative price of protein is equal to this relative satisfaction at the margin. That is for one more cup of coffee. And then let's get rid of those annoying minus signs. And there it is. There is our condition for maximizing utility given our income. But notice that we can rewrite this by dividing through the prices appropriately. And there is the same condition that we had talked about yesterday in terms of modal analysis. So this simply says that we should substitute coffee for carrot cake until the value of another cup of coffee is the same as the value given up of carrot cake per penny spent. In the graph, we make the substitution of coffee for carrot cake by moving in the southeast direction. And there is the interpretation of the tendency. So there is a Cook's tour. There's a very short tour. The idea behind utility maximization, when we're talking about two goods that are substitutes for one another. Okay. Questions so far? So I will give you some exercises that you can do for extra credit to get some practice with indifference curves and budget slopes. So now let's return to our extra credit exercise. We have already characterized the allocation of protein per cake in terms of what yesterday was just an algebraic solution right here. However, what would be more useful is if we can write down a demand function for X rather than just the amount that we would buy given particular prices and income. So the problem now is to derive Anastasia's demand function for coffee given any prices and income. I think this will take you about 5 minutes to solve. For 5 points of extra credit. And then an additional 2 points if you're the first to solve the problem.
Professor, excuse me.
Big party, go ahead.
So we need to find the slope of the budget constraint?
In this case, the problem is even simpler than that. Yes, you can solve it that way, but it is probably easiest just to use this condition that we've already derived. So this assumes that we have found the tangency between the indifference curve and the budget constraint.
Thank you.
No problem. So there is the specification for this condition. And then your problem is to find the demand function for coffee or X in terms of prices and also of income. So X is a function of prices that we will assume are constant, they're parameters. It's also of income, which is also a parameter. This is a lot like what you did yesterday. The only difference now is that rather than specify values for income and prices, we will solve the problem in general. So yesterday, for example, you said the income was 90,000 KD. Now I'm asking you to find the function for copying the man given any income. 90,000, 100,000, 10 pennies doesn't matter. So you will treat the prices and income as variables this time. Variables and not particular values.
Thank you, it's clear.
Okay, good. Thank you. So why don't you take 5 minutes now to solve the problem, find the demand function for X, and I would suggest that you begin with this condition of utility maximization. Five minutes, and then we'll come back together and solve the problem for the class. Thank you. Okay, good, thank you. So, because someone solved the problem, what does the then function for x look like in this case?
I wrote it in chat, Professor.
In chat?
Yes.
Oh, yes, that is progress, and that's very good. Uh, in this case, however, we're looking for a more general function for coffee demand. That is, we will not specify the prices. Instead, we will solve for x in for any value of the prices in the end term. So the demand function will involve not values for the prices and for income, but instead it will involve all three characteristics as variables. They can change. They do not have a particular value. But your overall approach is just fine.
Excuse me, Professor.
Go ahead.
Sorry for interrupting you.
No, it's not any time.
I wanted to say that I used the condition for utility maximization in my solution, and then I plugged for what I solved for y, and then I plugged y in the budget constraint line, and I got this. So basically, I wrote here the equation in the chat. Like the first is the equation of the demand curve, and the second one is that, like I said, that if we want to plug some prices, we can do that and we will get x equals 5, but we can but the like major equation is on the top.
Okay, good. But remember that we need to have income or z as well as the prices of x and y. So
Okay.
pick us through your solution. So let's begin by simplifying the maximization condition, as you will call it. I've divided through both sides by y.
Yes, and I also multiply. Do we need? I made a mistake here. I put values in the denominator. So I plugged values in denominator, but I shouldn't have had done it.
Yes, that's right. Yes, good. So solve for the demand function in general for any prices or income. And then after you have that solution, you can plug in values. That's right. Good. So we're going to solve for x in this case. By multiplying through by the price of y. And then dividing through by 2. Well, which is essentially what you've already done. And with good progress, we have an expression for x in terms of the prices. But unfortunately, we have y in the problem rather than income. a demand function by definition depends only on prices and income, not on other goods. So we need a way of getting Z into the problem. And you never get on the budget constraint. You spend all of our income. So on either X or Y, there are expenditures on X, here are expenditures on Y. But notice that now we have an easy way of getting income into the demand function for X. On the right-hand side, we have expression for expenditures on Y. So I've subtracted 3x and x from both sides. This just says that the amount that we spend on carrot cake is whatever we have left over in the income after drinking coffee. So now let's make the substitution for this term right here in the numerator on the right-hand side. And then divided by 2 times the price of X. And then finally, we will want to solve the equation for X exclusively. So let's write this out in terms of 2 terms. And then let's simplify. And then finally, just solve for X by adding X over 2 to both sides. Simplify on the left-hand side. And then finally, divide through by 3/2. The 2 cancel out because they occur in both the numerator and the denominator. And there is a solution to the problem. There is our demand function expressed in terms of the variable G or income and the variable P of X, which is the price of X or the price of coffee. Notice a rather interesting point. We don't have the price of Y in this demand function. That is, that the price of carrot cake does not affect our demand for coffee, at least not for this particular utility function. Okay, so I think that's good for 5 points of extra credit for each student in the class. And then for additional extra credit, first plug in particular values. Into the demand function to check whether it's correct or not. And then finally, derive the demand function for Y turned K. And this also will depend on the prices as well as income. So that is your challenge for tomorrow. And then we will move on to talk about opportunity cost, about the second third of chapter 2. Okay, so far. So there are 2 main points for today. We can derive the mathematization condition with graphs, and sometimes it's very helpful. And we can derive the demand function in terms of variables rather than values. And that's it, I'm done. Questions? Suggestions? Okay, so I will see you tomorrow. And if you wish to have extra credit of up to 7 points, try problems 1 and 2 right here.
Professor, excuse me.
Thank you.
Sorry.
Go ahead.
Can you please check? I wrote the solution. I found the solution for Y, and I plugged in the values in the chat.
Just for X, that's correct. So
Yes.
for Y, let me hold off until tomorrow so that everybody has a chance to try that solution. But I
Okay.
can say that you are on the right track, yes. I can go that far.
Thank you.
Oh, thank you. Other questions? Okay.
No.
Dusty Dunya, I hope you will enjoy reading further in chapter 2, especially the material on corruption at Merrill Lynch. Very interesting.